In this video, we're going to take a look at the first of the two light equations, which, using the speed of light, relates wavelength to frequency. C equals wavelength times frequency. We use Greek letters here to represent wavelength and frequency. Let's break that down. Now, the speed of light, c is the speed of light. Maybe you've heard of E equals mc squared, Einstein's famous equation. In that equation, c is the speed of light. For our purposes, the speed of light you're going to use to do your calculations is 3 times 10 to the 8th, and that's meters per second, which to put that in perspective, that's 300 million meters per second, roughly 7 times the Earth's circumference. So that means, yes, a photon of light could circle the Earth 7 times in 1 second. Pretty darn fast. We're going to use scientific notation. C, our speed of light, equals 3 times 10 to the 8th, and that's meters per second. The other two terms in this equation, we have wavelength, which we're going to measure in meters. And again, when you do these equations, units have to match. So we're going to use wavelength in meters so that it matches the wavelength in our speed of light. The other term is frequency, measured in 1/seconds or hertz. And that's a measure of how often a wave of light passes a given point in 1 second. So C equals wavelength times frequency. Now let's look at an example. Imagine that we have 425 nanometers of light. That wavelength would correspond to a dark blue, something in the blue indigo range of the visible spectrum. And let's say we want to calculate the frequency, bing, of that wavelength of light. So to do that, we're going to use our equation. So C is the speed of light, 3 times 10 to the 8th meters per second. And that's going to be equal to, I'm going to steal our little equal sign here, our wavelength. Now you may remember in one of the previous videos, we converted 425 nanometers to meters. To do that, I take the decimal and I move it to the left 9 places. And that's the same as dividing by 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, then I can put that in scientific notation. And when I do, I get 4.25 times 10 to the negative 7th. That's our wavelength. And that's going to be multiplied by frequency. So that's our setup for the equation. Again, I want to know what the frequency is of this blue wavelength, this blue photon of light. Keep in mind, photons are particles of light. All right, now the next step then, I'm going to rearrange the equation to get frequency by itself. At this point, it just becomes algebra with very large and or very small numbers. To do that, I divide both sides of the equation by our wavelength. So I'm going to divide 3 times 10 to the 8th by 4.25 times 10 to the negative 7th. And by doing that, that will tell me what the frequency is, okay? Now when I divide that, frequency equals this very, very large number. Now keep in mind, light moves very fast. I said earlier, right? It moves, I can circle the Earth 7 times in a second. So these photons, these particles of light, are very, very frequent. So our frequency here, 706 and 12 more zeros, and that would be in hertz, or 1/second. Put it in scientific notation, which you should do. It's going to look like this: 7.06 times 10 to the 14th, and that's hertz. So that many photons of this particular wavelength of blue light pass a given point in 1 second. And that's how we use our equation. Keep in mind this and other relevant information. If you have your periodic table for the class, if you turn it over on the back of the periodic table, mid right-hand side, you'll see this information listed under light formulas. Be sure to use that. Okay, do your best, everybody. Thank you.